A big shark. Oh, are you serious? I'm afraid of sharks, and I don't want to see it again until 6 o'clock tonight. But when I tried to understand sharks and dissecting sharks, I got an inspiration, which is segmentation. How to obtain a globally unique, monotonically increasing, and flexibly customizable ID can actually be solved by segmentation. If one ID cannot solve the problem, use multiple ID combinations. Just like a train, it is composed of carriages. Some cars are VIP areas, and some cars are economy class. Earlier, we introduced 4 ways to obtain a unique ID in a distributed environment. However, in a distributed environment, sometimes we want to create a more flexible ID. That is, we can even customize the ID format we want. So, how to obtain a globally unique, monotonically increasing, and flexibly customizable ID? This is a difficult question, because it is in a distributed environment. Moreover, there are other complicated factors. I am very afraid of sharks. When I came to the beach to swim, I told you a secret. I hid a hacksaw in my luggage. Wow, you must never think of what I am going to do next. The shark must be very curious whether my hacksaw has its teeth hard. Well, try it. Through this, I have an idea. Just like my shark is pieced together by fish head, fish body, and fish tail, data can also be combined in this way. Oh, and the locomotive. This machine identification. This timestamp, data identification. And then, put them together according to the rules you want. Good idea. Below, I will introduce a solution that meets the requirements of being globally unique, monotonically increasing, and capable of flexible segmentation. Come. It is the Twitter snowflake algorithm. The ID produced by Snowflake is a 64-bit number, and the binary structure is as follows. Each part is separated by. Well, the Twitter snowflake algorithm consists of the following parts. The first digit is not used. The next 41 digits are millisecond level time, The length of 41 digits can be used for 69 years, from the 1st of January 1978 hours 0 minutes and 0 seconds, and then the 5-digit data center underscore ID. Maximum support 2 to the power of 5 equals 32. The binary representation is from 00000 11111, which is 0 to 31 in decimal, and 5-digit worker underscore ID. Maximum support 2 to the power of 5 equals 32. The principle is the same as data center underscore ID. So data center underscore ID asterisk worker underscore ID supports the deployment of up to 1024 nodes. And finally 12-bit is the count within milliseconds. 12-bit counting sequence number supports each node to generate 2 to the power of 12 equals 4096 ID sequence numbers per millisecond. All the digits add up to 64 bits, which happens to be a long type, converted to a string length of 18. Its advantages: high performance, low latency. The number of milliseconds is in the high position, the auto-increment sequence is in the low position, and the entire ID is trending increasing. Moreover, the realization of this solution does not rely on third-party systems such as databases, and is deployed in a service manner, with higher stability and high ID generation performance. You can allocate bits according to your own business characteristics, which is very flexible. Its disadvantages: it is very dependent on the clock on the machine. If the clock on the machine is dialed back, it will cause duplication of the number or the service will be in an unavailable state. Bye bye. See you next.